Hi, welcome to another mini lecture on precalculus. Today's topics are arc length, central angle, and area of a sector of a circle. So let's see, you're going to go back to a topic we talked about before, which is the following. If you have a circle, an angle that is formed at the center of the circle, this is going to be called central angle, alpha. Circle always characterized by radius, and the arc length that we have in mind is what is subtended by the angle alpha itself. Let's write this thing as L. Question is, what's the relationship between these three quantities? Of course, you have two of them, you can get the third one. We said when we talked about radians that definition of a radian angle was it's a ratio of the arc length in front of it, so it's L divided by R. If you take this equation and turn it around, you get L is equal to alpha R. So if alpha is measured in radians, we have this simple relationship. We need to always remember that L is equal to alpha R. Well, what if alpha was given in degrees? Let's call it angle A so that we don't get it confused with alpha. Angle A in degrees. Well, all that you have to do is convert it to radians. You remember that an angle in degrees divided by 360 is same as that angle in radians divided by 2 pi. Why is that? Because it's a fraction of a whole circle. This out of 360 and that is out of 2 pi. So if A is given, what you can do is divide it by 360 to see what fraction of a circle it is, multiply by 2 pi, and that is gonna be alpha in radians. So this is in degrees, so let me write it, put a little circle next to it so it's clear it's in degrees. And once you have alpha, then you can get your length as we have written here. So angle divided by 360, so that's a fraction of the circle, and then you multiply that by 2 pi r. 2 pi r is of course the circumference of the circle, and you multiply by the fraction of a circle, and then you have your length. So here we have two formulas to think about. Similarly, we might be interested in this area. That's what is the area of this sector. This is a slice of pizza that you see here is called a sector, and of course you remember that we said the area of the whole circle was of course pi r squared. Area of a sector well, it's going to be alpha fraction of the whole circle, so I have to take alpha divided by 2 pi, that's a fraction of the circle, multiplied by the area of the circle, pi r squared, and pi simplify, and I get alpha over 2 r squared. Area of a circle is going to be alpha over 2 times r squared. If the angle was given to us in degrees, again what we are going to do is to take that angle divided by 360, that's a fraction of a circle, the angle that we have. When I multiply by 2 pi, that is the angle in radians, and then I have to take that angle, divide by 2, and then multiply by r squared. When I simplify this, it becomes a in degrees over 360 times pi r squared. So let's understand it again. A in degrees divided by 360, that's the fraction of a circle. Pi r squared is the area of the circle. Fraction times the area of the entire circle is going to be the area for sector that we have in mind. So again, if you have alpha in radians, half of that times r squared. If angle is given in degrees divided by 360, that's going to be the fraction of circle, then multiply by pi r squared, and that's going to be the area of the sector. Now let me teach you another way of thinking about the area. This sector, let me draw it again. The sector looks like a triangle. Is that right? That triangle has a base. This L is the base. That is alpha times r. You remember alpha times r? That's the base. And what's the height of it? Height of it, well, the height, you might be a bit confused. What's the height here? However you draw this radius, that's the height. And all of them are of size r. Well, what is the formula for the area of a triangle? Half the base times height. So 1/2 the base is alpha r, height is r. You simplify it, becomes alpha over 2 r squared. So here is the area of the sector. Second derivation for of our formula. Okay, here's a circular arc, has a measure of 5 meters, and it is intercepted by a central angle of 16 degrees. What does that mean? You have a circle, you have a central angle of 16 degrees. So 16 degrees, well, 16 degrees is a bit smaller than this, but I don't want to make it so small. The arc itself is 5 meters long. So this is a circular arc, has a measure of 5 meters. What is it that we want to find? We want to find the radius. What is the radius? So we have two numbers, the length of the arc, the central angle being 16 degrees, and we are after the radius. So how do we think about this thing? We say, well, remember that if it was 360 degrees, if I were to go around this whole circle, the length I would get in front of it, which is this entire circle, to go around it, it would have been what, 2 pi r. You don't know what r is, but the entire circle has a circumference of 2 pi r. So if my angle is 16 degrees, what would be the length in front of it? Well, take a fraction. It says 16 out of 360. Whatever fraction it is, that fraction times the length of the entire circle will be the arc that we are looking at. Well, how long is that arc? That arc is 5 meters. So I say this is equal to 5. Now I want to find r, so r I multiply, so this is my 5. I multiply by 360, divide by 16 times 2 pi. So the radius of the circle has to be 5 times 360 over 16 or times 2 pi. You use the calculator, enter all of them in your calculators in a single go, and after you're all done with that, you want to find the answer to the nearest tenth. Okay, so here we reasoned out again how to go about it. If you want to use this formula, that would be good too. So let me rewrite this thing. We have L, what was the formula over there? We had made L is 360. Let's go back, look at it again. Let me color it. The length of the arc is the angle divided by 360. So A divided by 360 times 2 pi r. That's the formula we described. All that you have to do now is to put various quantities that you have. So this is 5 is the length of the arc, 5. A is 16 degrees. 360 is the fixture here, 2 pi, and then r is what we are after. So here's an equation. How do you solve it? You can take 360, multiply both sides by 360, and divide by 16, divide by 2 pi, and that gives you r. So if you wish, you can make a different formula for yourself. Like if you want the r, if you want to insist on having a formula, r is take the 360 multiplied by L, 360 multiplied by L, divided by 2 pi times your central angle. So if you want to calculate the radius, you turn the formula, turn it around, and then you have your formula. It's better to just have the reasoning in your mind and one of the formulas at most, and then derive whatever you need later on. So either way, that would be fine. Here is another version of this problem, except that the angle now is given in radians. So let's go and practice that one. Excuse me, this is this is about area of a sector. So let's do an area of a sector problem. So area of a sector, we said area is equal to central angle divided by 2 times r squared. Is that right? So area of square is central angle divided by 2 times r squared. R alpha is central angle in radians. So what do I want to do? I have my radius, that's easy. So alpha is pi third. Take half of that, so half of this, times radius, which is 5.5 squared. So again, all you have to do to enter all these quantities in Alex calculator in a single go, calculate this thing, and again to the nearest tenth you want to figure that out. And here's another example. This one, central angle is 75 degrees. That's a difference between this one and the previous one. Radius is 9. So instead of using this clean-cut formula that we had here with radians, if the angle is given to us in degrees, we have to convert it to radians and then be done with that. So in this case, we say I have an angle of 75 degrees. What is the radian equivalent of that? So I say 75 divided by 360 times 2 pi. So I divide by 360, multiply by 2 pi. Then the area that I want is alpha over 2 times r squared. So my area is going to be half of this, so 75 over 360, 2 pi over 2, so that's going to be just pi, times my radius squared. So my radius is 9 centimeter, and then I have to square that. So these 2's cancel if you wish. So I have 75 pi over 360 and then 9 squared. So again, the angle, central angle divided by 360 times pi r squared, that's going to give us our area for the sector. Once again, you calculate with the calculator in a single go and you get your answer. Here is the area for this problem. I have another example here, finding the arc length so it says a circle has a radius of 6 meters. So we have a circle, radius of it is 6 meters. The central angle is 5 pi 6. 5 pi 6 is a big angle, so like this, we talked about this special angles, 5 pi 6. What we want is the arc length. Arc length is this S. So what was the formula for S? So we had several quantities here. We had S, we had R. So let me draw in a separate picture. So we had radius, we had the angle, and then previously we had called this thing L. For the length, sometimes they use the letter S. Okay, it would have been more natural to call it L for length, but it's customary to refer to length by the letter S. So it's the same way. So alpha is, in this formulation, is S over R, or S is equal to alpha times R. So this is nothing different from what we had at the beginning. We had called it L. Now the book likes to call it S, whatever. So our S is going to be angle, which is the big angle, 5 pi over 6, and then the radius is given as 6 meters. So 6 meters, well, 6 and 6 cancel, and S becomes exact 5 pi. This is, again, is asking you to the nearest length, so you multiply pi with 5 here and round it to the nearest tenth, and then you'll be all done. Okay, so what is the item we learned for today? We have length of the arc, so we can call it L or you can call it S. So let's write S or L, S or L. So we have these formulas for the length. You can rearrange this thing to get your angle if you want. You have to be comfortable writing this formula 3 different ways. This is in case it was given in degrees. Similarly, we had formulas for area of the sector. So area of the sector, alpha over 2 times r squared, or if it is given in degrees, So it's a fraction of the circle times the area of the circle. Okay, so until next time, good luck and God bless.